Cool. Hey, thanks, Richard. That was cool. Okay, so I'm going to spend kind of 20, 25 minutes talking about containers. Before I do that, how many people have used containers so far? So about 5%. And of those, anybody used it in production or testing? Any kind of thing? One or two. Okay, so it's very small. So as I was saying in the keynote, I think that containers is probably one of the first technologies, that and serverless, that are truly cloud native. They've been bought around this kind of notion that I need to look at new ways to take the existing applications that I have, move them to the cloud in the simplest way, in simplest form, and with things like DevOps and CI/CD, having a consistent approach that's really efficient for people. So I'm going to spend a little bit of time going through containers. I'm going to do probably like a bit of a 101, given the number of people who put their hand up, and then also show you some of the more advanced things. Demo gods. I noticed there's a networking issue a little bit with Richard's, but hopefully all that's going to work and we can show you some more advanced capabilities there. So containers, so basically what are they? So if you think about it, if you've got an application running on a server today, or you're even running in a virtualized environment, what you're trying to do is get one or many applications all running on that same box. And that's fine until there is a new version of an SDK, and suddenly you have this massive clash between different applications all trying to run on that same machine. The concept that we have with containers is that we have this concept of packages, and what they're doing is decoupling the application effectively from the operating system and from any other applications that are actually running in that environment. So it makes it really easy for you to build something with a very clear setup and then deploy it anywhere knowing that it's going to work. So the container itself includes the code, includes the runtime, obviously the operating system, some tools, some libraries, and obviously some settings so that the application kind of has an idea of what they're going to do. As I was saying, it makes it really easy for you to have this consistent deployment approach. And so, pretty much once you've got that container configured with your application, you can almost guarantee it's going to work wherever you place it. So as far as why, lots of reasons. Lower cost. I think the first thing is because these containers are getting really small in size, and there are companies like CoreOS, certainly in the Linux space, that literally took the whole of Linux and started ripping out everything they didn't really need. These containers are super small, and it means we can get a very high density of containers running on a particular appliance. So that means it saves you hardware, power, and software. I've talked about DevOps efficiency, so it means that I can have a very consistent pipeline for building my software and deploying my software that's consistent, and it means it can scale to pretty much the highest degrees we need. Talking about that, obviously this means you get great business agility in building your applications. One of the things that we're seeing, and we're doing quite a lot of work with some pretty large enterprise customers right now, some you wouldn't even think of. What they have is a lot of legacy applications, in one case, over 1,000 legacy applications. And they just want to bring them all to the cloud, but it's very complicated to do it as it is. And so they want to have an approach where they can literally lift and shift and put them all into containers and then bring them to the cloud using some of the techniques I'm going to talk about in a second. So this is the area we're seeing right now, but I also expect that for new people and new applications, this is probably pretty much going to be the model that people start to use for building their applications. So traditional machines, obviously virtual machines, you've got an operating system, you've got your application. With a virtual machine, you've got a similar kind of approach. With containers, it's a little bit different. You've got your hardware, you've got your host OS, and effectively, you've got a kernel, which is then being shared across a bunch of containers. And so those containers are then running inside that operating system. And they're completely isolated from everything else and from all the other applications in that environment. And they have all the runtimes and settings they need to be successful. So containers can run inside virtual machines. I even go into some details of, we have a technology inside Windows Server called HyperV. And in fact, containers could actually even run directly into HyperV as well. And I'll go into that in a little bit as to why you might want to use that. But there are multiple configurations you can do, and ultimately based on this simple atomic package. As far as how things are constructed, there are two basic principles. The first is you need a kind of a base image. And I mentioned CoreOS. For Windows Server, we have something called Nano Server. I'm not sure how many people have heard of Nano Server. This is the truly stripped-down version of Windows Server. I would say, if I was to be honest, that Nano Server is still a little bit big. And the engineering team are doing some work to make it even lighter. So right now it's about a gig, I believe, and they're trying to get that less than a half a gig by I guess your springtime. But yeah, so it's a small container. What you're then doing with that container is placing in your code, your application you want, together with some settings and some pointers to actually what you want to do. And so the way we do that is through this concept called a Docker file. So this is a Docker file example. I'm going to show you some code in a second. But basically what you're doing at the very top is saying, hey, for this particular application, I want this version of the Nano Server. I want to set up my ports in a certain way. I'm going to bring the application that I want to be placed into this Nano Server from this particular pointer. I want to expose that as on port 81. And here is the entry point. And this is a classic example. Some of them get a lot more complicated. And that's all that's required. And then when you actually build the image together with your application, it creates this container that then can be run and executed. So let me just do a quick, is this okay? Let me just do a quick demo of this, if I can work out how to translate to the demo machine. No. 441. Okay, cool. So this is, I guess I should be in a bash shell, but I'm not. I'm in the command prompt. So I have a very simple application. So this simple application, effectively, what it's doing is just responding with a message, and we can. I've just noticed you were doing it, so we can do Sydney. So I'm going to change that a little bit. What I've created is a little command file. And what this is doing, it's doing a .NET restore for NuGet packages for .NET. I'm building the app. I'm placing it into a publish folder, the completed file, and then cleaning up. And what I'm then doing is a build using Docker to an image, which I call. And then once that image has been created, I'm actually running it. And then finally, once that image is running, I'm actually doing an inspection to actually get the IP address. Let me just look at just to give you an idea, this is the Docker file. And so if I bring this up a little bit, whoa, no, not that far. Yeah, so this is Docker. So you see it's pulling out the ASP.NET container. It's pulling the ASP.NET core, which is actually part of Nano Server. It's defining the working directory. You see it's pointing to that publish directory, defining the DLL that it wants to run, and that's it. That's all it needs. So what I'm going to do is I'm actually going to run this run this command. So it's doing that restore, building the application. That all worked fine. It's now creating the container, merging the operating system with the applications, copying from the publish directory, as you can see. And it's now running the app. Cool. And it's now the application's going. So if I do this thing called Docker PS, you'll notice that this container is now running. And if I now take this IP address and run it, you'll see you can see that the application is now running. So that's basically Docker in a nutshell. Obviously, it will be really simple for you to use it for doing web applications. And you can imagine that process you can use over and over again, and you can actually also build that into tooling itself. Okay, so let's move back to slides. So the container ecosystem. So this is really important. So obviously, I did lots of manual stuff there in a batch file. I could use PowerShell. I could use some Docker APIs. But there needs to be an ecosystem that can make it really be usable in mission-critical, highly scalable situations. So we have containers from Windows and from Linux. Obviously, you saw me. You can control those containers through the command line. But the big innovation right now is this concept of container orchestrators. So DCOS, Docker Swarm, and Kubernetes. And as I was mentioning, also Service Fabric is also able to become an orchestrator as well. And what they do is ultimately build up the full environment. You're deploying the container to that environment with the configuration, and the orchestrator is managing the placement of that container or containers over different environments. If a particular app fails, it recognizes and then moves it over and makes sure that everything is completely persistent. So that's kind of the ecosystem. That's an orchestrator is kind of a very important part of how you'd run things in full scale. So as far as Windows servers, there are two options. We can run Windows Server containers natively. What we're doing there is we're actually sharing the kernel across multiple containers. And the real benefit there is that you reduce the amount of memory footprint because you're sharing the kernel. It means you can actually get really high speed and also really high density. One thing that you've requested, however, is, hey, there's sometimes I'm in a very hostile environment where my containers are being potentially pushed very aggressively via the web, for example. And so what we can also do is place containers and have them controlled through HyperV. So in that case, it's a little bit different. It means that every instance needs its own kernel, but you also get a lot more robustness for those containers running. But obviously, the density is a little bit less. So containers in Azure. So how can you do containers? So very quickly, we have something called the Azure App Service. This is kind of very much the high PaaS offering. You can have hybrid type of applications where you have your container running in Azure, probably having the database still running in your data center. We fully manage the whole environment for you and ensure that you kind of have a very highly productive environment. Great. This scenario is really great if you have a single container. So if you've got a single app, a big web app, App Services is a great scenario for you there. When you actually build up the solution, you have a number of options. You can actually, and I'll get into this in a second, but you have this concept of both public Docker registries and private Docker registries. And when you actually go and build your application, you've got options of both. Obviously, the private is the Azure private version, where you've placed your containers for other systems to collect. Think of it as your store for all your containers. So that's really simple, and it's a great way to get started and start to host some of your first web applications. The second area is Azure Container Services. And so, as I was saying, if you want to start to deploy a large number of containers, a large number of applications across a number of services, then you really start to need to orchestrate that. And so what we have to help you with that is something called Azure Container Services. This allows you to quickly, with literally a very one-line CLI, spin up, for example, a DCOS or a Kubernetes cluster of your sizing, and then through simple commands allow you to deploy those containers to those environments. Management is all through CLI, but also you have great access through the Azure portal. Lots of cool features. As you see here, things like managed disk support is really important. So for example, you may have a MySQL or a Mongo database. If that container crashes, you want to make sure that you have persistence. The orchestrators will handle all that kind of stuff for you. Azure Service Fabric is another option. Azure Service Fabric has been predominantly used to build microservice architectures, where you've got a large application split up into a number of different components, and you want to run that across a number of nodes for durability and for scalability. SQL Server or Azure SQL DB is a classic example of one of those such applications, but Service Fabric is used predominantly inside Azure to run all our PaaS services. Now, Azure Service Fabric also allows you to do full orchestration. I'll show you an example of that in a second. So you can run both Windows Server and also Linux containers side by side and manage those. So as I was saying, as far as why you'd use Service Fabric, it's fantastic for lift and shift, particularly if you're in a Windows Server environment where you just need to start to move those applications. Service Fabric runs both on-premise on a Windows machine, also in the cloud. So you've got the option of, hey, I want to still keep my apps local, but I actually want to run them in this new container model. It's great for, obviously, microservices and mixed levels of containers, both Linux and Windows. One of the things that Service Fabric's got as a capability is it's very good at recognizing when a particular node is getting hot, and will actually start to move containers around to make sure that we don't completely overload a particular node, so that certain applications become less responsive. So this concept of noisy neighbor. The final thing before I go and do a final demo is Containerized Workflow. And this is where I think the magic happens. And once you start to think about this from a developer practice, it kind of gets really interesting. So you've got obviously your normal kind of, I call it the inner loop. You've got your basic development you're doing locally. Rather than just writing code to an operating system that has to be fully configured, and you know how long it takes you sometimes to get all your systems up and the right SDKs and the right whatever's settings and database connections. What I'm doing is I'm going to just always deploy my application to a container that I'm going to configure. So I use Docker, I use a registry to get my container, and I'm actually building and testing locally my application. Once I'm complete with a certain build, I can push this to my source control. So it could be VSTS. There are also other Git-enabled vendors that can do this. I do the build. And in the build process, what I'm doing is actually pumping that back to the, in this case, the Azure registry, where I'm saving a copy of that version that now works. So this is my, my container copy. And then at deployment, I'm simply taking that container from the registry and then deploying that to my container orchestration system. So that can be obviously through Azure Container Services, it could be Service Fabric, App Services, or all the different models that you want. So once you start to do that, and once you start to build that loop, it becomes very easy for you to go from local testing and validation through a whole CID process to actually deploying that to a cluster. And with a far more higher guarantee that the end result's going to work when you actually deploy it into production. Obviously, the final outer loop is, hey, adding things like application insights allows you to get some telemetry on the application and then move from there. So some of the things we've done, and this I'll just do a demonstration of this. So Visual Studio 2017, we have some preview components, and what they're doing is effectively building containers right into the product. So rather than having to build your own environments, you can stay inside Visual Studio, you can build your application, and then when you actually go to test and deploy, you're actually testing it and deploying it inside local containers, making sure it works before you actually then deploy that through your CID framework. There's full breakpoint debugging, and a whole bunch of, it supports a whole bunch of Docker support, so it will actually do things like create your Docker file for you. There's also another thing called a YAML file, which I didn't have time to go into. So it will actually handle a lot of that work for you to help you configure your application. So to finish with the 4 minutes I have left, I'm going to hopefully now get back. Cool, get back to my demo machine. So we have this application, so a simple visitors application, and fingers crossed we have network. If I actually look and do a view here, it doesn't work. Okay, so while that's not working, so let's move on to something else, and we'll try this again in a second. Oh, it's working. Oh. Okay. So imagine this is an existing application that you've been using for a while. It's built in .NET, and just trying to work on the different steps that you could take. So the first thing we've done with inside Visual Studio is here's a particular part of the application, my website. I can actually right-click and go down to Add, and then I can add what we call, you see here, Docker support. What it's going to do is going to do analysis of the project, and hopefully you can see this. What it said is, remember we described the Docker file. Hey, this is the framework we're looking at. This is the working directory. This is where the source is going to be, and this is where we're going to publish from. So it's generated a Docker file for us. So we can go through. It's also built this thing called a YAML file, which helps us in also more settings and configuration. So at that point, we've started to build a Docker-based application. Going back to my finished application now, again, I click on here, and for whatever reason, I've got a slight problem. Continue. Let's go through again, see why. What you would normally see is this is the application running. It's actually running in two separate containers. I won't show the commands, and you'd actually see the debugging actually working and passing, going through a debug breakpoint on two different containers before going back to the final application. For whatever reason, at the moment, it's just it's only going to the one. Let me just do one last try. Nope. it's for whatever reason not working. Okay, let's move on. So you built your application. The final thing you can actually do with your application is in the solution itself, I can actually deploy continuous delivery. In continuous delivery, I can actually pick the branch that I want to pick. It should say master. I can pick the host type. You can see Linux and app services. We're going to have more. We'll also support Kubernetes here moving very shortly. So I actually start to deploy my application to the cloud to CI/CD. And what that means is that I can deploy my application. I then go through a full build process in the cloud. I can do my NuGet restore. I build my solution. I'm then using Docker, so Docker functions right within inside the STS to containerize, to deploy that to the Azure Container Registry, and to actually lock that. So it's actually then ready to be used elsewhere. I can then, as my next step from a deployment phase, in this case, use Service Fabric. I'm going to, again, pick that same container. I'm using this concept of this YAML file here to actually deploy the application to, in this case, my Service Fabric cluster. And then once you've done that inside the Azure portal, I can start to look at this is my Service Fabric cluster. I have 5 nodes, 114 applications. And inside that, I get a very good set of telemetry for the health of my applications. I also get, as part of the telemetry, a lot of analytical information that shows me the performance of the different containers and the different nodes in my machine. So that's the full end-to-end round trip. And I say, unfortunately, I don't know why the full debugging wasn't working within my application. It's been running all week, but that adds the support for Visual Studio. So with that, I think we have a 5-minute, if you want to get ready, a little 5-minute finish. From a containers perspective, this is only the beginning. This is going to grow. It's something I would hope all of you kind of take a look at and do some research into. I think once you get used to it, this is going to be something that you're always going to want to do. And I say it's very much a cloud paradigm. From a next set of pointers, go to microsoft.com/containers for kind of high-level information. And also, if you go to the basically docker.com, their hub, you can see all the different containers that are available from a Microsoft perspective. So with that, hand it over to Andrew.
Thanks, Neil. Okay. That's awesome. So thanks again, Neil. I think you've got a really good overview this morning of some of the very neat things that are happening more generally with Microsoft, but also particularly the AI on the bots piece. And I wanted to finish this little segment with a quick chat with someone who's building bots for real here in Sydney. So Wayne Acton from Apps for Ops, thanks for joining us. Mate, tell us a little bit about who you are and what you guys do.
So Apps for Ops is basically a platform that it automates common business operations, things like expense claim, timesheets, receipting, invoicing, things like that. All our apps are workflow-enabled apps, so they work well in isolation or really brilliantly together.
Yeah, that's very, very cool. So enough talk. Perhaps let's just show us what you've got. You've got a bot here, so we can switch across to the demo machine if we wouldn't mind. Thank you very much. And you've got a bot here running in Skype. Tell us about what's going on.
So basically what you're currently seeing, the conversation has already started. There's been some questions asked, and currently we see a help menu giving the user kind of an idea of where to go, what he can do next.
So this is a key thing, right? This is one of the interesting things about designing for a conversational UI is if you want to have a conversation, then you need to understand what context the conversation is, how you can talk to people, and in this particular case, how can you talk to the bot? You've given us some hints about how you can talk to the bot.
So let's try. So obviously we need some context of who you are as the user talking to Skype. So let's try signing in.
And this is one of the patterns that we talked about, that Richard talked about beforehand, where we're going to go out to an external service to actually to authenticate. So you've just put the user ID in here.
So today we're signing in as Sheila, giving it the email address. So what's happening in the background, it's going off, making sure it's a valid email address. Hit on connect. I'm already signed into the browser as Sheila, and I can give it permission to continue.
And so behind the scenes is a bunch of talking back and forth between the bot and the back end to make sure we know who you are. And now you've got a completely different list of things that you can do.
Once you're authenticated, it's obviously completely different, and we can start off with asking for a list of tasks.
And this is all the things that you might have to get done.
Exactly.
And you could be doing this when you're on the road or wherever you are. And you've presented these in the cards that we were talking about.
Yes, exactly. So these are all the cards. You've got different actions. One of the actions will take you out to a web browser again if you want more detail around the task.
And once again, I want to call out the fact that you've got a little hint in there that says, you can also filter your tasks by saying, show me the things that are doing for expense claims or whatever. You're giving people hints about how this stuff works. That's very, very neat. And you can also, you can filter again by thinking, what are my tasks for today, or those sorts of things. Or you can drill down into the more detail about a particular thing. Now, I have to say that I don't know if anyone else has noticed, but it doesn't sound like Australian is your native language.
Not exactly.
We could perhaps try a different language. You apparently also speak German quite fluently.
Yeah, so let's see if we can speak German to the bot, and let's see what it does.
So what's happening here is that the cognitive services doesn't recognise this particular phrase, so it goes off and says, "Hey, something's gone wrong. We'll try that again."
Yeah, let's just.
That's not what normally happens, but that's okay. So it'll go off in the background. It goes off and says, "Hey, I think you must be speaking another language, and I've detected that it's probably German. Would you like me to continue to speak in German?" But notice it said that to you in German.
Yes.
And you say yes. And now all of the UI has been translated. It says, okay, now I'm speaking to you in German. All of the UI has been translated into German, and you can say help. And in German, help is Hilfe. And it gives you that help, the same help as you had before, but it translates the entire UI. Now, behind the scenes, what's happening is your bot is running exactly the same way, but just in and out of the bot pipeline, it's running through the translation service.
Exactly. So now let's just do the same thing, asking it for a list of tasks. And it should bring back the exact same list, but in German.
They are, and including the hint, the things you can say still with the translation stuff.
Exactly.
That's very, very neat indeed. So let's just switch across the slides again for a sec. I just wanted to point out that you've actually done this not just, of course, for Teams or Skype, but a bunch of other another bunch of other platforms as well. Yeah, so you've got going here in Messenger and in Teams. And Skype and on the web.
As well,
That's very, very neat indeed. All right, so mate, what I might get you to show now, we might skip the Q&A Maker bot. We'll just go back to our demos though, because I did want to make sure that you showed off a very cool thing you guys have got in testing at the moment, not in production. So we've actually got a video of it rather than trying to run it live on stage. Tell us what's going to happen here.
So basically what you're going to see, you're going to actually make a call to a Skype bot, and you're going to hear somebody talking to the bot and asking it a question, and the bot responding.
All in audio,
all in audio, no typing's happening. So the use case is you're driving your car somewhere and you want to do some work, and you can call a Skype bot and actually interact with it.
Awesome. So let's just run this.
Hello, you have come to the Apps for Ops slot. What would you like to do today?
How many tasks do I have?
You have 2 tasks. Anything else?
No thanks.
Thank you for talking with me. Goodbye.
So I love this. I think it's a round of applause. That's a very, very neat implementation. Well done, you guys. That's very, very cool. So Wayne, you and Sean will be around for the rest of today. So if you want to ask about how this stuff works, then please find the guys in the lovely black Apps for Ops shirt.
Yep.
And I would certainly encourage you to check out some of the bot framework stuff that's going on with us. So with that, thank you very much. Please enjoy your morning tea, and we'll see you back after the break.
Awesome. Very nice.